This is lesson 1 of chapter 7. In this chapter, we will talk about naming chemical compounds. So the title of the chapter is Chemical Formulas and Names. Beginning with chapter 7, we're going to start talking about not individual elements, but compounds. Most of the world is actually made of compounds. And compounds, remember, are more than one element chemically bonded. And here are some compounds for you. And on the left side, I've actually given you ionic compounds. On the right side, I gave you covalent compounds. Remember that each one of these, there are two different types of compounds, ionic and covalent, and we're actually going to review both of them, and then we'll teach you how to name both of them. So first, going over ionic compounds. Ionic compounds, that word ionic refers to the fact that you have ions in them. And ions can be positive or negative. The positive ones are called cations. The negative are called anions. And they are formed whenever there is a transfer of electrons from a metal to a nonmetal. If you remember that metals have low electronegativities, and because they have low electronegativities, this means they don't want electrons. They want to actually give up an electron. Nonmetals, on the other hand, have high electronegativities, which means they want to accept an electron. Another way of thinking about this is that here's the periodic table. Here you have the nonmetals, and the nonmetals want to be like the noble gases. Remember, you have the noble gases nice and stable in this last group. The nonmetals want to gain electrons, go to the right to become like noble gases. So they'll want electrons. The metals, which are on this side, actually want to go to the left. They want to lose electrons to become like noble gases. That's how sodium, for example, becomes like its closest noble gas, neon. And so the picture you see here is here's sodium. Sodium will give up an electron because it doesn't want electrons. Chlorine, which is a nonmetal, will accept that electron. There'll be a transfer of electrons from the metal to the nonmetal. The metal then becomes positive. The nonmetal becomes negative. And what happens is these two then bond together to form an ionic compound. This ionic compound will be called sodium chloride, and we will learn how to name these. So this is a review very quickly of ionic compounds. Ionic compounds look like this at the molecular level. We have alternating positives and negatives. The purple here then would be the sodium plus ion. The green would be the chlorine minus ion, as is appropriate for chlorine, nice and green colored. And these form crystals. On the large scale, on our scale, we can sometimes, if we do this carefully and slowly, we can form crystals. And this is reflecting the ordered structure at the molecular and atomic level. So this is how ionic compounds look. And here are the rules for naming ionic compounds. The rules, actually before, not the rules for naming the compounds, but the details of these ions. So you can have, ionic compounds can have monatomic ions in them. These are ions formed from a single atom. The word mono means one, from a single atom. In this case, chlorine, or magnesium, or oxygen, or just one element. Every element, we can say, can become charged, can become an ion, except the noble gases. And then you have polyatomic ions. Polyatomic ions are ions formed from two or more atoms. The prefix poly actually means many. So here is an example, NH4. Notice you have more than one atom. You have 5 atoms here, more than one type of atom. So this is a polyatomic ion. It's still an ion because it has this charge. It has a plus charge, which means it's a plus 1. If there's not a 1, or if it just says plus or just minus, it means it's 1. This one is also a polyatomic ion because it has more than one atom. It has sulfur and 4 oxygens, and these are monatomic ions, polyatomic ions. Apologize. And here is the rule for forming ionic compounds. Ionic compounds form so that the plus and the minus charges cancel each other out to form neutral compounds. This will be the big rule which we'll use to form our ionic compounds. In other words, the number of positives must match the number of negatives, and we'll have to make sure that this happens. So if we take a look at the periodic table, it says atoms from the S and P block usually form only one type of ion. So recall that the S block is on this side of the periodic table. This is your S block. Your P block is on the right side of the periodic table. Here's your P block. And what we're saying is that these elements form only one type of ion. If you recall, the first group 1, called the alkali metals, form a +1 ion. Group 2 form a +2 ion. Now they do so because each one of these elements, for example magnesium, wants to be like the closest noble gas. Its closest noble gas is neon. And magnesium will lose 2 electrons because it has 12 to become like neon, which has 10. When it loses 2 electrons, you get a +2 charge. That's because when you lose negative, you become more positive. So same thing with the P block. If you take a look at group 17, which are the halogens, they have a -1 charge because fluorine wants to become like the closest noble gas, neon. It will do so by gaining an electron. Fluorine has 9, neon has 10, so it will gain an electron and become -1. So the oxygen group has a -2 charge, the nitrogen group a -3 charge. Recall that the carbon group can be plus or -4, and the boron group will actually be +3. A famous example, aluminum wants to be like neon again. It has 13, neon has 10, it will lose 3, and that's how it has a +3 charge. Now here it says except Sn and Pb. Some of these elements down here actually will have more than one type of ion, and that is because they are more like the D block. They belong more to the D block in terms of ions, and in the next slide we'll show you that the D block elements, these elements here, have more than one type of ion possible. So here it is. Atoms from the D block, these are called the transition elements, usually form more than one type of ion. And you can't know these just by looking at the periodic table. For the S and P block, if you look at the periodic table, if you're in group 2, you know it'll be +2. Every one of these elements will be +2. If you're in group 1, every one of these elements will be +1. Group 17 will be -1. Now, if you're in the D block, you can't directly know. Iron, for example, can come in 2 varieties, 2 flavors. It can either be +2 or +3. So you have to be given other information to determine. You can't just look at the periodic table because this element can form 2 types. And we'll show you how to find this out. For now, just understand that you have 2 types, more than 2 types. 2 types of ions possible, or more, for these ions. And the next slide actually shows some pictures of 2 types of iron. This is iron +3. This is iron +2. There are 2 types of iron out there. The +3 iron is actually red, and this is what composes the red soil in many parts of the world, including the United States. It's also what gives our blood the color red. It's because the iron, along with another organic or biological molecule, team up to give you this red color. The black iron is +2. This is a different form of iron, and this is actually famously used in tattoo making. And remember, think before you ink. Tattoos are pretty much there to stay. So these are the 2 types of ions. If you had, for example, magnesium, magnesium comes only in 1 variety. There is no 2 different types of magnesium. Magnesium is only +2, never anything else. But iron, naturally, can be +2 or +3 because it's from the D block. So this gives us a little more information. And here is a little more information about polyatomic ions. We said that these are ions that are composed of more than 1 atom. You don't find these on the periodic table. And these are very common, though. You'll find them all over the world, all over the compounds. In fact, you have many of these at your house. And these are the 6 I want you to memorize. There are more than 6, but these are the 6 most common that we'll use throughout the semester, second semester. So let's go through them. The first one, OH, with a -1 charge, is called hydroxide. The second one, NO3, with a -1 charge, is called nitrate. SO4, with a -2 now, is called sulfate. CO3, with a -2, carbonate. PO4, -3, phosphate. And the last one has a strange name. It's NH4 with a plus. This is the only one that's a cation. The rest of these are actually anions. They're negative. This is the only one that's positive. And this one has a strange name, ammonium. Now, what you have to memorize are how many oxygens. Notice that each one of these, actually, almost all of them, it's how many oxygens they have. The 8 at the end actually refers to a bunch of oxygens. A bunch of oxygens. So you have to memorize how many, and then you have to memorize the charge. So this isn't as easy as it looks. You actually will have to spend some time trying to memorize these. And there is a way of using these. We will teach you how to use these. These are just common polyatomic ions that you find all over the world, all over the place. Okay, there are more polyatomic ions. Obviously, these are not the only 6 in existence. The others, I don't want you to memorize. You don't have to memorize unless you want to impress some friends. But here they are. Some of them, for example, chlorate. Here's good old chlorate. Here is permanganate. This is a fun one, permanganate. I'd recommend memorizing that one. How about cyanide? This is a good one. This is a fun one. Cyanide, very dangerous, poisonous compound. It's also the initials of Chuck Norris, and this is not a coincidence. So feel free to memorize some more of these if you'd like, but you don't have to. In the next lesson, we'll talk about how to use these to name actual compounds. But for now, this completes for us lesson 1 of chapter 7.